An absolute value function is a function where the input value is inside of an absolute value. The graph of absolute value functions form V's. Which makes sense because if we go negative and we input a negative into an absolute value, our output is positive. And if we input a positive into our absolute value, our output is also positive. To graph this V-shaped graph, we first need to identify this point right here. That point is called the vertex. In the general form of an absolute value function, the vertex is going to be an ordered pair, and it's going to be at the value h, k. So our x value is the number that's being subtracted from x. It's the h value, it's the value of x that makes what's inside the absolute value 0. And our y value is just going to be this number at the end, k. So once we know where our vertex is, the next thing we need to do is identify how this V is shaped. To figure out how the V is shaped, we need to look at the slope of the V. Now I'm going to put slope in quotations because this isn't a true line. It's actually two pieces of a line. It's actually a piecewise function. So the slope of the line is this value right here that's in front of the absolute value, our A value. Now our A value is going to tell us a lot. If A is positive, our V is going to open up. If our A value is negative, our V is going to open down. And that kind of makes sense. A positive means opening up, and a negative means opening down. The A also tells us how steep our lines are. So we need to look at the steepness of this slope. And the steepness of the line will tell us how narrow or wide our V is. If we have a large steepness, a value that's greater than 1, we're going to have a narrow V. If we have a small steepness, a value that's between 0 and 1, our V is going to open up wider because our slope is going to be less steep. Let's look at an example. First, we need to identify the vertex. The vertex is going to be an ordered pair. The y portion of our vertex is just going to be this value right here. In our case, positive 3. The x portion is a little tricky to figure out. It's the value that's being subtracted from x. Well, in this case, we don't have a subtraction sign, we have a positive sign, we have a plus sign. So in reality, this is x minus negative 4. So what value is being subtracted from x? It's actually negative 4. The other way you can think of this value is we need to find the x value that will make this, our absolute value, 0. What do we need to input for x to make the absolute value 0? Well, in order to make this 0, x is going to have to be negative 4. Next, we need to identify our slope. In this case, our slope is negative 2. So negative 2 is negative, so our V is going to open down. And negative 2, has a steepness that is more than 1. So our V is going to open narrow. To graph this absolute value function, start at the vertex. So we're going to plot the point negative 4, 3. From there, we're going to use our slope. Our slope is negative 2. So I'm going to go down 2 and to the right 1. Down 2 and to the right 1. And I'm going to continue this all the way across my graph. Now I need to form the other half of my V. I'm going to go down 2, but this time I'm going to go to the left 1. I'm forming the other piece of my graph. Now I need to connect these dots, because this will be a continuous function. And I've now graphed my absolute value function. Let's look at how this absolute value function actually works. What happens when x equals 1? Well, when x equals 1, what happens to y? Well, let's plug in x to find out. Y is going to equal negative 2 times the absolute value of 1 plus 4 plus 3. So let's do that math. Negative 2 times the absolute value of 5 plus 3. The absolute value of 5 is 5. So I have negative 2 times 5, which is negative 10 plus 3. Negative 10 plus 3 is negative 7. So when x is 1, y is negative 7. If I input 1, my output is negative 7. If I input 1, my output is 1, 2, 3, 4, 5, 6, 7. So this input-output relationship, this input-output function, makes sense on my graph. What happens if x is negative 5? Well, I'm going to plug in negative 5 for x. Y is going to equal negative 2 times the absolute value of negative 5 plus 4 plus 3. Order of operations says do what's inside the grouping symbol first. Negative 5 plus 4 is negative 1. Now I can evaluate the absolute value. The absolute value of negative 1 is positive 1. Negative 2 times 1 is negative 2. And now, last, I can add. So when x equals negative 5, y is going to equal 1. When I input negative 5 for x, my output is 1. When I input negative 5, my output is 1. If I used all of these x values, I'm going to get all of these points that are on the graph. So this graph is a graph of all of the input-output values that make this equation, this function, true.